Hello everyone and welcome to the basic probability rule. So today we are going to discuss some basic probability rules that form the basic foundation for everything we will use in this course. So let's start with very basic probability rules. The first rule says probability of event A is between 0 and 1, or greater than or equal 0 and less than or equal 1. 0 if we have probability of phi. So probability of phi equals 0 because phi is the empty set. There is no elements in the empty set. This is why probability of phi equals 0. And probability of the sample space, or S, equals 1 because the sample space contains all of the possible outcomes. So probability of the sample space is 1. So probability of any event should be between 0 and 1, right? So if we have two mutually exclusive or disjoint events, such as the following. Suppose this is our sample space, or S, and we have event A and event B, and those events are disjoint, as you see, or mutually exclusive, or there is no overlap or common elements in both of them. In this case, probability A union B equals probability of A plus probability of B. So let me give you an example of probability of the union of two events. Suppose we have two events, like probability of, you flip a coin. When you flip a coin, you get tail or head, right? So what is probability of getting tail or head? Right? So union means or. So I'm sorry, T or R. R means head, right? Probability of getting tail or head. Now, because those two events are disjoint or mutually exclusive, like suppose this is T, this is H, there is no way to have like overlap between them. In this case, this is simply probability of getting tail plus probability of getting head, right? And we know probability of getting tail is 1/2 or 50%. Probability of getting head is 1/2, so the answer is 1. So we use this formula if A and B are disjoint or mutually exclusive. How about if A and B are not disjoint or not mutually exclusive? We are going to discuss this in the next slides. All right, the next is a very important formula in probability. It's a short formula, but it's very powerful formula. The formula says probability of A complement equals 1 minus probability of A. Why is that? So let me explain here in the Venn diagram. Suppose we have a sample space here, and we have the set A, and we have the complement of A, which means all of the elements in the sample space that are not in A. So everything is outside of A is called A complement, for example, right? Now, as you see, A and A complement are disjoint events or mutually exclusive events because there is no overlap, no common elements in A and A complement. So A probability of A union A complement equals probability of A plus probability of A complement, right? Why? Again, because of the previous formula, that if we have disjoint events, then probability of the union equals probability of the first event plus probability of the second event. Now, what is A union A complement? A union A complement, as you see, is the entire sample space. So this means probability of the entire sample space equals probability of A plus probability of A complement. And what is probability of the entire sample space? It's 1. So 1, or probability of the sample space, which is this, equals probability of A plus probability of A complement. Therefore, probability of A complement, or you can simplify or write the formula here in a different way, probability of A plus probability of A complement equals 1. And from there, we have the conditional probability that probability of A complement equals 1 minus probability of A. All right, next we are going to discuss the additive rule. The additive rule, as you see, for any two events A and B, probability A union B, or you can say probability A or B, equals probability of A plus probability of B minus probability of A intersection B. Some of you may say or may ask this question, why do we subtract probability of the intersection, right? So let me explain here using Venn diagram. Suppose we have our sample space S, and we have the two events A and B. This is A, and this is B. Okay? And A, this is A, all of the elements in A, and this is B. Now, if you calculate, or if you write probability of A plus probability of B, this means you count the overlap twice. As you see in the overlap, we have two colors, right? They have some elements of A and some elements of B, so we count them twice, right? So this is why we have to subtract probability of A intersection B. So in this case, we count the overlap one time. All right, so this is the general formula. Probability A union B in general equals probability of A plus probability of B minus probability of A intersection B. Now, is there any connection with the formula that we just discussed 5 minutes ago? That is, if A and B are disjoint, then probability A union B equals probability of A plus probability of B. Yes. So actually, that formula is a special case of this formula. So this formula is for probability A union B. This is the general formula. Probability A union B equals probability of A plus probability of B minus probability of the intersection. Now, if A and B are disjoint or mutually exclusive, this means there is no overlap. So the overlap is the empty set or phi. So this guy or this probability is 0, right? So in this case, probability A union B equals probability of A plus probability of B. So this is the general formula. And the old one is a special case of that formula when A and B are disjoint or mutually exclusive. Next, we are going to discuss an example. Suppose we have two events, A and B. Probability of A is 25%. Probability of B is 40%. Probability of A union B is 55%. Find the following. Find probability of A complement. All right. So from the complement rule, probability of A complement equals 1 minus probability of A. This is the complement rule. And probability of A is given. It's 25%. So 1 minus 25%. So the answer is 75%. That's it. This is probability of A complement. B, what is probability A intersection B? All right, now we haven't learned probability of A intersection B so far, but we know probability A union B in the formula. There is probability of the intersection, right? So let me remind you, probability of A union B equals probability of A plus probability of B minus probability of A intersection B, right? So probability of A union B is given, which is 55%. Probability of A is given is 25%. Probability of B is 40%. Minus probability of the intersection, and this is our question, minus probability of A intersection B. So here, 0.4 plus 0.25 is 0.65. All right, so probability A intersection B should be 10%, right? So probability A intersection B equals 10%. So 65% minus 10% should be 55%. All right, the third one, probability of A complement intersection B complement. Now here we have two complements, and I mentioned before, when you see two complements, think about De Morgan's law, because probability of A complement intersection B complement using De Morgan's law, this is probability A union B complement, the complement of A union B, right? And probability of A union B complement equals 1 minus probability A union B using the complement rule. So probability of the complement of any event equals 1 minus the probability of that event. And it's given the question, probability A union B is 55%, so 1 minus 0.55 is 45%. All right, so I hope everything is clear, and that's it. Thank you very much for watching.